Thank you very much for taking the time today to view our video. Before we begin, we'd like to take a moment to introduce ourselves. There are many aspects to 9.connects, but it boils down to the fact that we're a PCB-centric organization. We believe and focus on the PCB due to the fact that it is truly the center point of all electronic design. That's where our expertise lies. We provide services not only in the PCB layout, but in design consulting as well. And during the technical portion of this webinar, you will see this expertise in motion. We are now the exclusive North American instructors for Altium Designer. We host 100 trainings throughout the year across North America, and we are excited to bring these trainings closer to you. In addition to our services, we are also a value-added reseller for a number of PCB-related software companies. And just to note, each company has been presented in past webinars. So if you're interested in them, please contact us or check out our website. And by the way, we provide one-on-one coaching for these tools as well. For more information on our services and past webinars, please contact us. Our information is listed in the description below. Thank you for giving us a moment of your time, and please enjoy the presentation. Well, thank you very much for joining me today. This is going to be a very simple overview of the SPICE simulation capabilities within Altium Designer. It's certainly not meant to be exhaustive. It's really been put out there because of requests that we receive quite often in regards to the simulation tool in Altium, and it's not necessarily an intuitive methodology, and so I just want to spend a couple of minutes talking about it and running through a real example over here. So I am using a buck power supply example here. So this is one that we've drawn up. You can see it over here. And the first thing that you kind of need to know about doing simulation in Altium is that every single component that you have on the schematic must have some type of SPICE model associated with it. Whether it's a simple resistor or you start getting into something like a Zener diode over here, you definitely need to have some type of model for it. Now, certain ones Altium already provides for, it's just a matter of enabling it. So let me click into the resistor because that's obviously one of the easiest ones. So when I click into its properties, I'll go down over here to the model, and I can easily add another model if I ever want to. Okay, so you can see that there's the ability to add a simulation model. But in this case, I'm just simply going to select on the one that's already here, so I'm going to click on Edit. And so it's going to bring up the Sim Model Editor here. Okay, and there's 6 tabs. Most of them you don't really have to worry about too much. The first one that's over here is really what I call the pseudo code for SPICE. You got to keep in mind that SPICE is over 40 years old. It was created at UC Berkeley, and it was written as basically a text language. And if you still want to write as a text language, you can certainly get the original engine to do that, and Berkeley makes that available to you. And what they would do is they would have a designator, or they would have a letter, and that letter would represent an element. So the letter R at the very beginning character of the tool or of the program would represent a resistor, C would represent a capacitor, L would represent an inductor, and so on and so forth. And there's a whole list of these things, and there's books out there and probably even web pages out there that will show you what they are. But the very first letter basically tells the SPICE code what we're dealing with in terms of an element. And then from that point on, it needs a few more pieces of information. Now, in the case of a resistor, the default information that it needs, and you can add different things to this as well, but the key things it has to have in order for the code to work is something with the letter R as a prefix. Then you would have its first point or its first node, and then its second node, and then the value. Okay. Now, in the case of Altium, it's kind of crazy to think that one would have to create a file for something this small over here. So if you click on something like resistor, Altium's going to do that for you automatically. Here's the netlist preview, so you can see that this one's already connected up. So it's connected from RS2, and then the first node that it's connected to is ground. The other node is this thing called netC2_1, and then this is 10, and I think this is 10 milliamps. One thing about Altium as well is that Altium can use those prefixes like K's and M's and so on and so forth. You got to be careful about the prefixes because a little m and a big M in Altium means something very different, where M means milli, or little m means milli, and a large M means mega. So just be a little bit careful about it. But Altium can read that, but it will not read anything really past that information. So if you actually put, for example, 10 ohms, after the M, Altium's going to ignore it. And by the way, that's also true for things like 2V5. If you put 2V5 in the SPICE simulation, it's going to only see 2V, and it's going to drop the 5 and anything after that. So just something to keep in mind. So some of these over here is just a matter of clicking on to the model subkind that they provided and just simply filling in the blanks at that point in time. Others, which are a little more complicated, you may have to get a model from the company that makes the component. And we'll look at an example of that in just a moment. And then here's a model file. Well, in this case, there is no model file required because it's a simple resistor. Over here in the parameters, we do have to give it a value because we can easily declare a resistor, but it needs to know what the value is. And by the way, value is a really important, what I'll call key parameter in Altium. So if you call something value in your parameters, in your properties of the component, Altium is going to read that. So make sure that that word value is kept sacred if you're going to do SPICE simulation. And then lastly, which is very important, is your port map. Now in this case over here, it really doesn't matter because we're dealing with a passive, and whether the component is flipped or not is not a big issue. But you'll see in a moment where your pin mapping can be very important, especially if you've got very specific ins and outs of a certain component like a FET or something of that nature. So that's all been set and done here. So let's get into a component that's a little more complicated. Let's take Q1 over here. And what I'm going to do is I'm going to double click into, again, the simulation. So in this case over here, we're dealing with something that was provided by a company. And they can provide it in one of two forms. They can provide it in a .ckt or in a .mdl. A .ckt is really your classic circuitry that you would write in SPICE. And as a matter of fact, this one has a combination of both of them. So let's go over here to the model file for a minute. And if you look over here, and I'll pull this up a little bit wider, and anything that's kind of in this grayish color is basically a comment in SPICE. But what you're seeing over here is a sub-circuit, and they're actually setting this up in the traditional form that you would expect to see in normal SPICE code, where what you do is you declare a sub-circuit so it can be used in a larger circuit, and then you declare the name of it, and then you also declare the pins of it. So in this case, the first pin here is called drain, the second pin is called gate, and the third pin is called source. And you will see that these will be used here as nodes throughout this entire code here. So for the example that you see over here, the first thing you see is an LD. In this line of code, what this is representing is representing an inductor. So the prefix L, the very first character on that line, says this is an inductor. Anything after that is really just to provide more detail as to which particular inductor you're talking about. So they call this one LD. And then they're talking about the node here. So this is the node drain over here, and there's probably another node here, and then some value, okay? And it keeps going on and on. So the next line after that is a resistor, another resistor on the third line, another inductor on the fourth line, and you can see how this kind of keeps going. Now, towards the end over here, what you're going to see, which is kind of neat, is you're going to see this thing called a dot model or a dot MDL. So sometimes these models are provided as dot MDL files. And so you have two ways of doing it, that if you want to use a pre-existing model, you can certainly do so. The problem is with it is that SPICE has a very definitive set of what models it can take in. And this gets a little trickier too because of the fact that there is a fundamental difference between SPICE and PSPICE. Now, SPICE was the first thing that came out, and it was made widely available free of charge to anybody who wanted it from Berkeley. Now, at that time, you had to pay a little fee for the tape or the cassette so that you could put it onto your machine because there was really no there was internet, but certainly not to what it is today. So if you wanted a copy of it, you had to pay a small fee for it. But once you had the copy of it, you could do what you see fit with it. And a lot of companies took it and did a lot of in-house simulations, and they did a lot of in-house development of their own SPICE tools. Well, one of them actually kind of took root, and they started selling it out in the market, and that's known as PSPICE. And so PSPICE actually started to become more widely popular than the Berkeley SPICE. And they even created elements and they added things to the models over here that the Berkeley SPICE did not have at the time. Well, I don't know if it was by mistake or coincidence or on purpose, but when Berkeley came out in the late 80s with an update over here, they not only did not take several of the things that PSPICE had, they also they basically created conflicts with certain elements. And again, what I mean by an element is what the first letter is over here and there was, I think in particular, it was the E element and the B element where PSPICE declares it one way and SPICE declares it another way. So as a result of that, you have a fork in the road, which has never really been fully reconciled. So you just got to keep that in mind, that if there are parameters over here that Altium doesn't read, it's because Altium cannot read PSPICE because it's owned by Cadence Design Systems. It is not open source. It is proprietary. What Altium can do is it can read it into the extent that PSPICE follows the nomenclature and the coding of the original Berkeley SPICE. So in fact, when I run this, you're going to see that there's going to be a little bit of an error because one of these here is PSPICE related, and Altium will continue to run it. It will flag it as an error, but it's basically going to ignore it. Okay, so that's just something to keep in mind here. So there is a bit of a history over here, and the way that they wrote this code over here kind of lends itself to some of these problems. But that's what we've got over here, and until Berkeley or someone else really tries to take the entire SPICE simulation code and do something completely different with the engine, we're kind of stuck with these the way the code was initially structured. So we'll leave it at that. So that's what these models are at this point. And by the way, a lot of companies don't really want to give you this type of information because it allows other companies to reverse engineer it. And of course, with these models being somewhat limited because of the fact that there's been more factors added in for better simulation, they can't fully rely on these things here. So as a result, what you're seeing is companies that are creating proprietary tools such as Linear SPICE Technologies or LT-SPICE, or even Texas Instrument with their WebBench and TI-TINA. They're purposely doing that because they don't really want to expose their code over here, which in turn allows other people to see what they're kind of doing. Okay, so it's a proprietary issue. So that's what you're kind of seeing over here with it. But that's, you know, if you can get the model from the company and its SPICE model, drop it on in. This situation over here, it's simply a matter of declaring it to be a SPICE subcircuit. You tell it where it's located, and as long as Altium can see it, it's going to read it into the code itself. The parameters here, let's just click on this. There's no parameters for us to necessarily set at this point, so we're not setting any values. And then the port map. And the port map is really important because this, again, is one of those archaic aspects of SPICE that make things a little bit tricky. Now, fortunately, whoever wrote this code over here did a great job with the naming convention here, with the name drain, gate, and source, because by default you can say 1, 2, and 3. And this causes a lot of confusion for individuals who have to set this up over here, because what you may have called your source, drain, and gate in your schematic, and possibly even with your footprint, don't necessarily match up with the model. Because what happens over here is it's not based necessarily on the name per se, it's based in the order in which these are placed, and that's what you're seeing over here. So why is there a number 1 next to drain? Because that's the first in the order. There's a number 2 next to the gate because that's second in the order, and there's a number 3 next to the source because that was third in the order. Okay, and so if this was 1, 2, 3, and this was labeled 1, 2, 3, this would be pin 1, and this could be pin 3 is pin 2 and pin 1, and so on and so forth, because it gets very confusing. But the way that they label these things over here makes it very easy to change those if you had to. Okay, so just wanted to give you kind of a heads up on that. So you can see that that's what we have to do for every single component. Now, in addition to that, you do have to add some type of power sources to it. So you have things like this VSCR, and all the simulation libraries, by the way, are provided with Altium. If you go into the examples directory, you'll find all of these. There's, I think, 4 or 5 of the libraries specific to SPICE simulation. So if I go here into the part itself, you can see obviously there's no footprint to this because this is strictly a schematic, a simulation representation. And again, we can go into its properties over here that change its parameters as such. And they've got quite a few elements. It's something to certainly take a look at. I think it's one of those really underused features of Altium. Now, with this being all set up over here, let's talk a moment about the project itself. So in this situation, we do have a schematic document, but it really needs to be saved under a PCB project, even if there is no PCB footprints or PCB associated with it. It has to be under here because it has to see the libraries that could be associated with it in addition to the schematic itself. It has to be put into a PCB project. So let me do a save on this here. So everything's all set to go. And now I'm going to do a compile on it. So I'm going to right click and compile it. Okay, make sure we're all good to go. Because a lot of times it could be syntactical. I want to make sure we separate those things that are SPICE related versus those things that are just simply an ERC issue that we may have. So if I go under System and take a look at Messages, and I bring it up, everything looks hunky-dory at this point. And I am going to leave this Messages panel up here because in a minute I'm going to run the SPICE simulation. You're going to see a few other errors that are going to appear here. All right, let's take a look at the some of the tool features over here. So these are the 3 tools that you will get if you right-click and you enable Mix Sim. By default, when you install Altium, this is not, it's simply not installed. And so you have to basically turn it on, and you'll get these 3 icons over here. The first one basically generates the entire list. In fact, let's see if I can bring that back up over here now that it pushed it out. Here it is. So this is basically generating a complete SPICE netlist. In theory, this could be ported over to another SPICE tool. It's using all of the commands that SPICE comes with. Okay, but there can be some variances and differences. Again, after that big split between PSPICE and Berkeley SPICE, there are differences that some tools can read in, some tools can't. They may ignore them, and so on and so forth. So, for example, if you were to try to pull this one into LT SPICE, for example, most of it will read in, but my understanding is that there's going to have to be some cleanup. So don't expect everybody to be universal in that nature. So it will create this for us. Let's go back to the schematic document. We're going to click on the wrench over here. So the wrench over here is really just two aspects. It's what type of analysis do you want to run? And these analyses are totally based upon the analyses that were built into the SPICE engine. Okay, so if you purchase a tool and it's providing something above and beyond what you're seeing over here, it's code that they've added in there to enhance the SPICE engine. Okay. These over here are the available signals, and these over here are the active signals. What does that mean? The active signals, these are the ones that are going to be monitored, or they're going to be looked upon once you execute on, once you basically run the simulation and based upon those those analyses that you've checked off over here. Okay, and there's quite a few things you can go into here. There's just a lot to each one of these. So it's just a matter of knowing what each one does here. And the literature that Altium has is pretty good on it. And by the way, as a side note, there's also a 2-day class that Altium provides every so often. And if you're interested in that, let them know so that they can try to schedule one of those in the near future. And they go through this rather with some depth to it. All right, now that we've seen that over here, I am going to kick this off. So I'm going to click on this little button here, Run Mix Simulation. And of course, I can run this up here as well. So at this point in time, I'm simply going to just run this, and I'm going to click on this over here. Now, you may have noticed that there was a flash on the screen. It does do a very quick preliminary, and then it starts to do it in a much slower fashion here. Now, yes, we do have some errors, and you can see this over here. You notice that the errors here, unsupported PSPICE parameters, okay, and that's what they're showing over here. Okay, it's having some issues because this must have been built for PSPICE, and again, Altium cannot read PSPICE because it is Cadence proprietary. Okay, and we're going to let this run through at this point in time. I'll also mention over here that Altium has a tremendous amount of capability with its what I'll call the charts, plots, and waves. The whole thing is considered to be a chart, and then the plots themselves are each one of these areas here, and then there's also the waves as well, which you're seeing here. And they give you a number of capabilities to do calculations on the waves. You can set up the plots in different formats. You can set up the charts in different ways. Once this is done as well, there's also a Sim Data tab over here that you can click on. And by clicking on that, you can add cursors in there. You can see the deltas between those two cursors and so on and so forth. So it does provide you quite a few tools in the making over here. And once this is done over here, I'll just click on this. Okay. And we'll click on the Sim Data tools, and you can see that if I click on some of these, I think we really need to get a cursor over here. So let me right click on a cursor here. So let's add cursor A, and once you've got cursor A in there, we can move this about, and then you can start seeing some information. And if I get cursor B in there, so right click and put cursor B in there, now we can get some delta information in there. Okay, and you can see this over here. And again, there's a whole bunch of different ways to get information from these plots. And even though there's stuff that wasn't necessarily plotted over here, all that data was captured in many cases, it does capture some of the information, so it's not necessarily going to be drawn out, because you can see it took a couple of moments to draw this stuff out, but it does capture information. Now, as for the tabs down below, they are strictly based upon those analyses that were checked off. In this case, there was operating point. So operating point doesn't really have any plots over here. It's just giving some general information. And then there's the transient analysis over here. So once the wave plots come back up, you can see it. So that's what I wanted to do with this very quick and brief demonstration here, is just give you a very general overview of the simulation tool in Altium Designer. So thank you very much for your time, and good luck in your endeavors.